The big question here is this: can you hunt for the new planet 9? And yes, we know about Pluto, that is the former planet 9, and that was actually debunked quite of long ago, but broke the hearts of many and pretty much changed everyone's textbook and gave us a little more insight into the true definition of a planet. This particular video, we're going to look at a couple of interesting journeys that a particular scientist and researchers are currently going through in search for this planet X. I know the article uses X as the Roman numeral, but think of it X as unknown, but in terms of position relative to our solar system, we're looking at planet 9, and this here will give us so much more insight into the research method and how this will probably open our understanding to maybe the presence of planet 9 out there that we can't detect yet, or not at all. This is a waste of time or money to invest in such research or endeavor. So let's dive into this particular video here right now. This here, looking at the research phase, focuses on the first question, which is why Pluto is not considered a planet. And there are three levels that Pluto actually went through to come up with that particular result. And the first here was that yes, we know that Pluto was discovered in 1930 by sky watchers, and this has been pretty much the golden rule or standard for the longest time. It is that yes, Pluto, or we have 9 planets in our solar system. However, in early 2000s, there was a discovery that hey, there are other worlds that are within that region that Pluto is currently located at, and this region here is known as the Kuiper belt. I don't know how to pronounce it properly, but hey, bear with me. And this belt is kind of like a massive donut, and it is known to contain a lot of what we know as the Trans-Neptunian objects, and these objects, they do behave like Pluto. And so now this led to the second phase, which focuses on a specific object that was introduced by Mike Brown and his colleagues, and this was around in the 2005. And this particular object, you can remember what I said, not planet but object, is called Eris. And Eris was something quite interesting in a way, because of course we know Pluto is around 39.5 astronomical units away from the sun. 1 astronomical unit is pretty much the distance from Earth to the sun, but in here this Eris is around 68 astronomical units away from the sun, and this shows some interesting promising results based on their findings that hey, Eris has the same behavior and it is slightly larger than Pluto. And so this came up as hey, is Pluto really a planet, or we have been getting this wrong all along? And so this led to the third phase, which is a group of astronomers who come up with the definition of planet. And the definition out of the three, one, Pluto did not meet the last criteria, so that made Pluto to be debunked or demoted to a dwarf planet. And this here is pretty much what the third point is. The third point says that Pluto, hey, doesn't really have a distinct orbit. It means that when you look at it at that particular regional belt, it shares orbits with other objects in that particular belt region. So because it doesn't have a clear orbit, that makes Pluto to not be a planet but a dwarf planet. Now, focusing on the hypothesis here, we're not going to be looking at the Kuiper's belt with these particular objects that we highlighted, but we're going to be looking at region beyond this Kuiper's belt. And this region here has objects that are known to be called the Extreme Tran-Neptunian Objects, and these extreme, or aka ETNOs, they are, in terms of my estimate, to be around 70 astronomical units, which is just further away from the sun. And this here highlights two objects and many more objects out there, but first is the Sadnia object, which was discovered in 2004. Is really important in terms of Brown's investigation, and this object is around 76 astronomical units, and while the other object is called 2012 VP113, and this is around 80 astronomical units. Now, remember that it's really difficult to identify all these objects that are further away from our system or from Earth. And so, looking at this, they came up with a hypothesis that hey, these ETNOs, they do have a role in discovering our ninth planet. And you might be asking yourself, why is that the case? And they were suggested that this planet or objects, like for example the Sadnia and the VP113, they oscillate around the heliopause. It's kind of like a putative boundary of our solar system, and it's kind of the space between the sun's magnetized winds and gas and dust from between stars. And it says here, according to this article, that this is too far for the gravitational field for the giant planets, like for example Neptune, to have any effect on this object's orbit. And so they said that hey, it is of course definitely the sun that is keeping those particular objects at their specific orbit, but something else may interfere with those objects orbit, as you will see in some images. And in 2014, it was suggested that something else is the hidden or is a hidden planet, and this hidden planet is estimated to be around 2 to 5 times the size of Earth in terms of the mass, which is quite massive in terms of their estimate. That slowly alters the orbits of these objects and position in space, and this is actually done over time. And so it's quite interesting to see this information hypothesis being brought up. I'm going to look at the experiments that was taken. Now, looking at the experiment, Brown and co, they focused on 6 of these ETNOs, and they used computer models to observe 4 things about these objects. First is that they had an elliptic orbit, and the second is that their orbit had a 20-degree tilt that is similar to that of Pluto's orbit with respect to our solar systems in terms of the 8 planets that are ecliptic in terms of the plane, and in terms of also the location, in terms of how this orbit approaches the sun. They all get closest to the sun at the same location for number 3. And for the 4th thing they observed is that they are, in terms of further away from Neptune, they are so far away from Neptune's gravitational field that doesn't really have an impact on their particular orbit away from the sun. And so the question is, if their orbit is so far away from Neptune's reach based on Neptune's gravitational field, then what makes them to be so further away from our solar system? And they came up with a result based on the computer model that there is an hidden planet that must have a mass that is not, in this case, 2 to 5 anymore, but now 5 to 10 times Earth's mass, and the orbit is around 700 astronomical units away. 700. This is not like in the tens anymore, we're getting to the hundreds. This is crazy, and this will have a greater impact on the object's orbit. Now, the orbit of this hypothesized planet should be around, in terms of the angle tilt, 20 degrees as well, from our ecliptic plane solar system. So really fascinating stuff right here. But hey, there are some skeptics in this particular research. Now, looking at the challenges that this particular hypothesis is facing, it all comes down to one, in terms of the style by which we need to view or locate planet 9, and the telescopes that we have currently, they are limited in terms of their ability to view objects that are that far away according to the proposed location, which is around 700 astronomical units, really far away. And using an observatory, this leads to two extremes. The first extreme here is a wide field view, and this here allows you to see the night sky in one shot, which is more of the night sky, which is really important. However, the other extreme is a massive mirror, and this massive mirror allows more light that is to be collected from a smaller area, and this allows you to see really distant and but however fainter stars or objects. Now, this here in this particular other extreme, which is the massive mirror, has a lot of drawbacks, which is that one, it is too expensive for we to find planet 9. And you might be asking, why is that the case? Of course, because it's too far away, and also it may not exist, which is going to be an unfortunate event. After many years of research, there are three alternative, I would say, hypotheses that have been put forward. Some of them have been debunked, and some of them are open to interpretation, let's put it that way. And so, looking at the first alternative hypothesis, it states here that planet 9 is not canonical but is a mass size, which is the planet that is in our solar system based on its size, that is one. And looking at its location, it's postulated that it is at the outermost level of our solar system, or it could be within the Kuiper belt as a Trans-Neptunian object. And this here, according to Caitlin Vaux in 2017. But this particular hypothesis have gone through a lot of research and has led to some debunking of this hypothesis, and she's kind of come up later on to state that, you know what, is a possibility that planet 9 is not that massive and is also not Mars-like in terms of the size. So that's interesting for the first alternative hypothesis. Now, looking at the second alternative hypothesis that came up in 2020, researchers actually gave an hypothesis that yes, maybe in an icy ring in primordial debris, it doesn't say which particular debris, could be the Kuiper belt, who knows where this particular debris can be found, but it says that this here could be so massive that it could impact the ETNOs orbit. Now, there is a little bit of a drawback with this, which states that this icy ice contains ETNO may be held by a massive planet, but it's really quite complicated when we are integrating the search for planet 9 into this particular hypothesis. And then the third alternative hypothesis came up in 2019, and it talks about maybe there was a passing star, or you can say a rogue planet, that may have dragged the ETNO's orbit along, or this could be a crazy one that was actually stated. It said that maybe a tiny black hole, and if you're looking at the mass in terms of relative scale, is around 7 Earth masses. And this year, according to Brown, said that it is ridiculous, but hey, still probable in terms of those alternate hypotheses. Now, looking at the drawbacks that this particular theory, which focuses on this planet 9 that is around 700 astronomical units away, there are a couple of interesting things that were highlighted. First is that the current technologies cannot see the full space clearly. The factor of the weather, and bad weather do inhibit or prevent us from getting a full scale of different segments of the sky. night sky. Another one also that was highlighted was that these ETNOs, they are captured better when they are closer to the sun than when they are further away from the sun, because their objects are really small and really hard to detect compared to regular sky stars. And in addition to that, looking at the location of our solar system in the Milky Way, it is known that it is around one of the arms of this spiral galaxy, and so this here allows us to view the stars lights way more than that of any object. That is because of the background that those lights are putting on from this research. And it said that they used 6 ETNOs, and these 6 ETNOs is considered to be not enough to predict the behavior of other unknown and unidentified ETNOs within that region in space, and therefore this represents a particular known bias as observational bias. To overcome this bias, what you need to do is to widen and brighten the view as well, which is you need to develop or improve that instrument that is going to be used to visualize those objects. So keep that in mind in terms of that particular information. Now, to improve this bias, currently what they did was that they used a particular survey which is known as the Outer Solar System Origin Survey, and this here combines both France, Canada and Hawaii's telescope to explore 8 patches of the night sky and identified how many? Around 800 new Kuiper's belt objects. And so out of these 800, 8 objects had distances from the sun to be on average 150 AU. That is indeed more than Pluto distance and also Eris. And so these particular objects that are 8 were marked as the ETNOs. These here are the important objects that are required for we to visualize a presence of a planet 9. And so the orbits weren't clustered according to their observations, which is not an indication that there were any massive planets around, because massive planets, what they do is that they allow objects to have a clustered orbit, but that wasn't the case. And this here was checked and was proven using a dark energy survey around the year 2020, and they came up with the same conclusion. We're still dealing with small numbers of the TNOs, and we need to be able to have more of them to actually check whether there is indeed the existence of a massive planet that is going to be marked as our planet 9. Looking at the improvements that I'll be taking to get this particular view on track, this particular observatory, that is a new one called the Vera C. Rubin, has a statistics that is mind-blowing, I must say. First is that it's going to be located on the mountaintop in Chile. And why this location? Because it's going to take the entire night sky all year, in terms of the view from the southern hemisphere night by night. So that means if we have one bad weather for a year, that means that segment that is missing will have to be taken the next year. So looking at what this looks like in terms of the build, it says that this is an upgrade in terms of the design, which is around, of course, looking at the weight, it's huge, 7,000 pounds, which is massive in terms of the weight. And this here is like a car-sized camera that is constructed in California and moved carefully and meticulously all the way to Chile mountaintops, which is really impressive, with no scratch at all coming from this article. And this here features a 3,200 megapixel camera, and the price in terms of the amount that was required to build this particular camera, guess the number. $168 million. That is crazy. That's a massive number right there. But hey, here's the mission that this camera is going to have to accomplish. The mission here is to capture from 4,000 objects before this camera to, with this camera, 40,000 objects. And this mission here will be automated, where nightly images will be processed by algorithms and released to the community to see whether we have more evidence of Planet 9 or not. Watch out for, and there is a presence of cluster orbits that is caused by massive planet or not. Another thing to watch out for is that, based on what we talked about previously, this helps us to rule out any observational bias, and this is because now we're going to be discovering hopefully more ETNOs, the planets that may reflect a lot of light, like Neptune or Uranus. This here might be due to high hydrogen enveloped orbs with many ice on that planet. So that may be something that we may come across in terms of those images. So some bright light might not actually be a star, it might actually be a planet similar to that of Neptune and Uranus. Now, my personal take on this is that yes, it's great that we have ETNOs to help us to determine whether there is a Planet 9, and this here might be helpful, of course, by using this particular observatory that is currently in the works. But then the more I read about arguments that are not in favor of the presence of Planet 9, but maybe some other factors that impact the ETNO's orbit, the more I actually just fall in line with that. The chances of finding a Planet 9 is really low. Look at those numbers: 700 astronomical units away from the sun. That is where Planet 9 is going to be located, relative to Neptune's distance from the sun, which is in the tens of values. That is a massive number in terms of the difference. And yes, there might be other things that may impact those and ETNOs in terms of that orbit. I feel that this article is looking at everything in terms of 1D or 2D planes, but if you look at it, there might be things above and below the plane of our solar system that may impact such ETNOs orbit. And as that is being changed from one gravitational field range to a different gravitational field range of our sun, that may impact definitely the orbit of such planets. And so it's kind of interesting how those ETNOs keep that orbit in terms of elliptic, but at the same time it's being held by two objects in terms of their gravitational field. And so, I mean, the ones that said that yes, we have a mini black hole that is some size of Earth impacting the orbit of those ETNOs, I mean, that one is like the chances of that happening is very, very low, I feel, for that. But then there are other things, like maybe a zipping star, which might be kind of something to question, or planet. Okay, I kind of think that might impact it. Anyways, this is a long video already. Let's just keep it short by you going down to the comment section and let me know your thought about this possibility. Do you think that there will be a Planet 9 that is going to be replacing Pluto, or do you think that we're going to end at number 8, which is the Neptune? All the same, please go down to the comment section and let me know your thought about this, but that way we can talk to you soon. Stay smart as always and believe in yourselves.